We'll start off here with the conclusion of our discussion regarding applying gesture drawing to compositional studies using perspective, the kinds of studies necessary to make drawings like the student examples we looked at in the previous lecture. You'll also learn how you can relate your knowledge of linear perspective to drawing freehand from observation. We separate things out like perspective in order to be able to study them up close, but each artist synthesizes all the pieces we've been learning about in his or her own way. Lastly, in this lecture, I'll introduce the basics of two-point perspective, how we deal with sloping planes, and give a brief introduction to three-point perspective. So, let's finish up our discussion of gestural compositional studies for perspective drawings. The idea is to run through a number of different ideas for a drawing with the goal of finding the best composition. In these small drawings, you don't need much detail, but you want to answer several key questions. What's the room like? What do the 5 major planes look like? Where's the horizon located? Is it high, mid, low? Where's that vanishing point? Is it right, left, or in the center? What's the drawing's format shape? Is it horizontal? Is it vertical? Is it square? What's the approximate scale of the grid measure at the baseline? And of course, you want to determine the subject of your drawing. All the other considerations should relate to this. Once you've answered these questions, you measure the compositional sketch you made and scale up the important measures. Start with your format shape. Do the same with the positions of the horizon and vanishing point. Next, you could draw the back wall and using a ruler, divide the vertical distance between the horizon and the bottom edge of the back wall into units. These units represent the eye height of the viewer in feet. You now have your scale and you can grid the back wall. And remember, we want to keep the grid light and thin. This is all construction line. It's generally preferable to adjust the back wall shape so you don't come out with fractional grid units on either axis. Then you can now project your diagonals forward along the ground plane. You can assess the first row of grid units from the back. Take into account the square grid on the back wall and the height of the horizon in making the first horizontal. Then use the rule of diagonals, this time moving forward in space to find successive rows. It's often preferable to modify the exact placement of the ground line or bottom edge of the format shape to accommodate a final full row of tiles. Once you have these 2 planes, project your side walls and ceiling. Then grid the rest of your drawing. With a completed grid, you're ready to make the drawing itself. If there are specific kinds of windows, doors, or furniture, or other objects you want to use in your drawing, search in books or online for images to get data. Then project what you learn about the planar nature of the objects into the specific perspectival position and in the specific scale you want. You now have the tools to dig into this project and create a believable environment from your imagination. You may want to go back and take another look at the student examples for this project. You could even make small gesture studies based on those drawings. It will sharpen your sense about how gesture relates to linear perspective. For most of the section on linear perspective, we've been plotting things out with triangle and T-square. But we've just seen that we can incorporate perspectival thinking with gestural drawing from our imaginations. And it can also be really useful applied to freehand drawing from observation. And for a range of subjects, still lifes, interiors, landscapes, it's useful for all of this. The knowledge helps you quickly see and understand what's going on in complex visual situations. A good way to practice this at first is to pick subjects that have a clear perspectival recession. Next time you're on a plane or train, take out a sketchbook. You'll see how all the seats and overhead bins are all united by diagonals moving toward a vanishing point. Or try sketching outdoors, looking down a street. You'll see how the cars parked along the curb all relate to the same vanishing point as the curb, sidewalks, and other elements. Find your eye level in the drawing. That's the horizon. Try to see how all the things around you could be conceived of as blocks, prisms, cylinders, cones, and spheres, all related to a ground plane and the horizon. Locate the vanishing point or points. Draw with horizontals, verticals, and diagonals related to those points. Start with large structures and move from the general to the specific as your basic measures are set. You'll remember earlier, I briefly introduced linear perspective as the final tool that would help us understand proportions. Well, let's take one of the observational drawings we did and see how we could have applied linear perspective to do just that. In an earlier lecture, we drew a deep room using Alberti's velo, using grid coordinates. We could equally have approached this using one-point perspective. This is one of the hallways I use for this project at the University of Washington. It's on the third floor of the art building right outside the classroom where I teach. If we used linear perspective to draw this, our first goal would be to locate the vanishing point in the horizon. And that's easy enough. Any two receding diagonals will yield this information. Here's how. Using our clock hands tool, we can measure a diagonal receding in space. Then, either by eyeballing or using a standard unit of measure, we can place the angle in our drawing. We'll make sure to extend it back beyond the end of the wall because that's where this angle will reveal the vanishing point's location. Using the same method, we'll add a second diagonal. Where the two diagonals intersect is the vanishing point, and that reveals the horizon's height. We can check for accuracy by holding a pencil horizontally in front of our eyes with one eye closed. We'll look at the alignment of the horizon in the drawing and compare it with what we see in the hallway. Looking at the negative shape that occurs between the horizon and the two diagonals is a good test, too. The vanishing point will reveal all the angles of the receding diagonals on the right wall. To draw them, all we have to do is locate their point of origin along the right edge of the drawing's format. To do that, we could eyeball the distances in relation to the horizon, or we could use a standard unit of measure. We also need to locate the back edge of the right wall. That will fix the termination of the diagonals. Alternately, we could have drawn the vertical of the back wall first. Then measured to find the relative position of the terminations of the diagonals. And, lining these points up with the vanishing point, bring lines forward to the format's edge. Once we have one wall, we could use level lines to identify the placement of events along the vertical axis of the second wall. The vanishing point, in combination with points of origin or termination, will give us the information we need to draw the receding diagonals. We can proceed the same way to locate the lights on the ceiling, and the tiles on the ceiling, and even the reflection of the lights on the floor, and the reflections of the walls on the floor too. So this one little point offers up a wealth of data. I think you'll enjoy applying one-point perspective to an observational drawing. Redrawing the room you did using the grid could be a good place to start. Another good subject is a road either in the country or a city going back into space. You can tackle any subject that has a strong one-point perspectival view. This will really solidify your ability to use perspective in a wide variety of ways. While one-point perspective is very useful, it has clear limitations. It's great for describing spaces like a receding hallway or room where the back wall is parallel to the picture plane, and the walls are perpendicular to the picture plane. And it's equally useful for describing objects like these boxes. Like the room, they each have a face parallel to the picture plane and other surfaces perpendicular, all at right angles. Vertical lines describe their height, horizontals their width, and diagonals receding to a common vanishing point on the horizon, their depth. But let's rotate the block on the left. In contrast to the block on the right, there's no longer a face parallel to the picture plane, and we won't be able to draw it using one-point perspective. Verticals still express the block's height, so that's the same, but the horizontals are gone. Now we just have diagonals shooting back in two different directions. Let's see where they go. One set of diagonals, 3 in all, vanish back to the right. That would be the right vanishing point. The other 3 go back to the left. That would be the left vanishing point. And this, as you've likely guessed, is two-point perspective. We use it to describe planes that are angled to the picture plane. Both of the vanishing points are located on the already existing horizon, and that's no surprise. Remember, the horizon's not a place, it's a function of eye height. Another thing to note is that we're seeing 1- and 2-point perspective objects at the same time, and that's perfectly normal. We have two boxes in different orientations. One is showing a face, the other an edge. We experience this all the time. You walk into someone's office for a meeting, you're looking straight ahead at them at their desk, you see the base of the desk is a rectangle, it's in one-point perspective. If the chair you're going to sit in is angled to the desk, it's in two-point perspective. If you're looking straight at your refrigerator, so its face is a rectangle, it's in one-point perspective. Someone comes along and opens the refrigerator door. While the refrigerator remains in 1 point, the door is now in 2-point. 1 and 2-point perspectives simply describe objects that are positioned differently relative to the picture plane. With 1-point perspective, there's a single fixed rotational position for our box. With 2-point, the possible rotational positions are infinite. Right now, we're seeing an equal amount of both the right and left sides of the box. Let's rotate it slowly to the left. As we do, you'll note that we're seeing less and less of the right face. And as this happens, the diagonals and the two vanishing points are being pulled to the left along the horizon. If we keep going, the right plane disappears and we're back in 1-point perspective. Rotate the other way around to the right and we'll see the inverse. We see less and less of the left face. The diagonals and vanishing points move to the right along the horizon, and finally, the left face disappears and we've returned to 1-point perspective. There's a factor I should mention that affects where the vanishing points will be. As you move closer to an object, the vanishing points move in toward the object. As you move farther away, the opposite. Let's take a look at the room we're in. It's a 1-point perspective room. The room and the two boxes all share a common vanishing point. All the vertical edges are parallel. All the horizontal edges are parallel. And all the diagonals receding to the vanishing point represent edges that are parallel. Now, let's rotate both the room and the box on the right to the left. And we'll keep them parallel as they rotate. You'll note that they share right and left vanishing points. And here's the principle. Objects that are parallel in nature will share the same vanishing point or points. This is true in both 1 and 2-point perspective. Let's leave the room where it is, but begin to rotate the box to the left. Now its diagonals and vanishing point move to the left. We see less of its right plane, and it's no longer parallel to the walls in the room. Finally, let's take the box on the left and rotate it so that we see more of its right plane and less of its left plane. Now, none of the objects are parallel. Each is angled differently, and each object has its own set of two vanishing points. If we reposition the boxes so that they're parallel to the walls, all will share the same 2 points. Here, in 2-point perspective, what we'll see of an object related to its location vis-à-vis the horizon is much like what we encountered in 1 point. Here we have two boxes below the horizon and we see a top plane and two side planes. Throw another two identical boxes above the horizon and now we see the bottom planes instead of the tops. Throw two more on the horizon and all we see are the side planes. So far we've been seeing the boxes as opaque structures. Let's make them transparent and see what's going on inside. A box or block has 12 edges. 4 describe its width, 4 its height, and 4 its depth. Drawing with line, we need 12 line segments to describe a transparent block. In 1-point perspective, vertical lines describe height, horizontals width, and diagonals depth. And this is just what we see in Leonardo's Last Supper. In 2-point, verticals still describe height, but diagonals converging to a vanishing point on the right describe depth or width on the right side of that object. Diagonals converging to a point on the left, depth or width on that side. And that accounts for most of the furniture in Van Gogh's The Night Cafe. The key to remember is that edges that are parallel in nature converge to the same vanishing point. Let's repeat what we did in 1-point here, but in 2-point. We'll draw 9 transparent blocks, 3 above the horizon, 3 straddling the horizon, and 3 below. Put a new sheet of paper on your drawing board in the landscape position. First, we'll draw a centered horizon line. In 1-point perspective, the vanishing point is generally located within the format shape. In two-point, it's common for one or both points to be located outside the format shape. If the points are too close together, you get distortion. This can mean doing a smaller drawing in a larger page so that you can locate the vanishing points outside the format shape. Another strategy is to attach several sheets on a long drawing board or on a wall. For this exercise, we'll place the right and left vanishing points at the far right and left edges of the horizon, at the vertical edges of the page. In two-point perspective, the closest part of a block to the picture plane is its edge. So we'll start by drawing 3 vertical lines on the horizon to represent 3 edges. Make each 1.5 inches tall. We'll put the first one right in the center at the 12-inch mark. We'll put the other 2 5 inches away on either side. And we'll add 3 more verticals 2 inches above these, then another 2 inches below. Lightly, 1 1/4 inches to the right and left of each of these 3 stacked verticals will draw a long vertical construction line. Let's start with the vertical on the lower right. Turn this into a block. From both the top and bottom, we'll draw diagonals back toward the right vanishing point and stop at the vertical construction line. Then draw the vertical. Now, we'll repeat these steps going to the left vanishing point, top to vanishing point, bottom to vanishing point, and define the depth with a vertical. From the top of the second vertical, we'll draw a line back toward the right vanishing point. And from the far right vertical, we'll draw one going back to the left vanishing point and intersect the line we made in the last step. We have an opaque block. Let's turn it transparent. Remember to draw the interior with a lighter and thinner line. From the right lower corner, we'll draw a line back toward the left vanishing point. From the far left corner, we'll draw a line back to the right vanishing point. If we've been accurate, a vertical extended from their intersection should connect to the back corner of the block. With that introduction, you're ready to draw the remaining blocks yourself. This is what it should look like. Using 1 and 2 point perspective, we're able to describe an object with planes that are parallel, perpendicular, or angled to the picture plane. We can also describe objects that are parallel or perpendicular to the ground plane. Now, that's a bit abstract, so let's take a look at an animated sheet of plywood and see what this means. Face forward, it's parallel to the picture plane and parallel and perpendicular to the ground plane. We're in 1 point. Rotate it 45 degrees on its axis. Now we're at an angle to the picture plane, but still parallel and perpendicular to the ground plane. We're in 2 point. Rotate another 45 and we're back in 1 point. Rotate and stop anywhere and we'll be in either 1 or 2 point. We could also lay it flat on the ground, rotate it in any which way, and it will be in either 1 or 2 point perspective. So we're able to use 1 and 2 point perspective to draw many different orientations of form in space. But the moment we tip the plywood up at an angle, or down for that matter, we need a new set of procedures. We call these kinds of planes sloping or inclined planes. We encounter them as streets going uphill or downhill, or pitched roofs or ramps. These are all examples of sloping planes. So let's take that piece of plywood lying on the ground. It's in 2 point perspective. We can see its vanishing points on the horizon, right and left. Let's leave the left front edge of the plywood on the ground, but lift the rear right edge up a bit. It becomes an ascending inclined plane. It's sloping upward to the right. Since it ascends to the right, its sides will now vanish to a point along a vertical line extending straight up from the right vanishing point. This line's called a vertical trace. The point where the lines meet is called the vertical trace point, or vertical vanishing point. The back edge of the sheet of plywood will still be defined by the left vanishing point. As we lift the sheet of plywood further off the ground, the point where its sides converge on the vertical trace moves higher and higher, and this changes the diagonals of the edges of the plywood sheet. This will continue until the sheet is perpendicular to the ground plane and we're no longer sloping, until we're back in unadorned two-point perspective. If we continue past the vertical, we begin to descend. We're sloping down. We're far from the ground plane, so the sides of a panel will converge to a point on the vertical trace way below the horizon. As the panel returns closer to the ground, the vertical trace point climbs up the vertical trace until we return to the ground plane and all vanishing points return to the horizon. If we were to lift the rear left edge, the panel would now be sloping upwards toward the left, and its edges would converge on a vertical trace going through the left vanishing point. As we continue to lift and then rotate the panel, we see the same relationships play out here as we did when we inclined the plane to the right. You've actually already drawn an object with multiple sloping planes, though we didn't speak about it in those terms. It was the open box we drew in the lecture that centered on proportion. Let's try something similar here. This is what we'll draw. But this time, instead of relying on observation, we'll use linear perspective to construct the drawing. Start with your page in the landscape position and draw a horizon line 7 inches from the bottom of the page. Then add right and left vanishing points about 1/4 of an inch from the right and left edges. First, we'll draw the block shape of the box. Start with a 2-inch vertical line 1 3/4 inches below the horizon line. 1.5 inches to the right of this, draw a vertical to represent the width of the box on this side. From both the top and bottom of the central 2-inch line, draw a line back toward the right vanishing point. Stop at the vertical. Erase anything you don't need. 2 1/8 inches to the left of the center line, draw another vertical. Then, from the center line, draw the top and bottom edges of the left side of the box, receding toward the left vanishing point, and stop at the vertical. Erase anything extra. From the far right corner, vanish left. From the far left corner, vanish right. And again, erase anything you don't need. To complete the box's base, add a vertical in the box's interior. Now for our sloping planes. First, we'll draw vertical traces above the right and left vanishing points. Let's start with the flap in the rear on the left. Place a vertical trace point 6 inches above the left vanishing point. Then, draw from the rear left corners toward that point. We can eyeball the width and draw a line to the right vanishing point to complete the flap. Let's move to the front right flap. Add a vertical trace point 3 inches above the left vanishing point and project lines out to the left from the box's corners. Again, eyeball the width and draw a line to the right vanishing point to define this. Note here that if we were to lift this flap up above the edge of the box, it would vanish to a point on the vertical trace below the horizon. Similarly, if we were to lower the rear flap below the box's edge, it would also vanish to a point below the horizon. Let's move to the rear right flap. I think you get the idea. Add a vertical trace point 8 inches above the right vanishing point and draw that flap. Add another 4 inches above the right vanishing point and draw the final one. Erase where the flaps overlap the box and you're done. If you want rigorous results, drawing the horizon, the vertical traces, and all the horizontal and vertical vanishing points will do the trick. But once you've done this a couple times, you'll likely have a reasonable grasp of the underlying principles governing these kind of planes. And for many purposes, you can dispense with all the ruled construction lines. As you begin to get a feel for this, you can eyeball where given edges should vanish. For many kinds of drawing, this will work just fine. You could practice this by setting up a still life of 2 to 3 boxes with open flaps so you have a good number of sloping planes. Make a couple compositional sketches, decide on a point of view and format shape, then make the drawing itself. Start with empirical perspective to get the essentials located. Then apply what we've just covered, but this time don't actually draw all the construction lines. Just try to imagine where they'd be and draw the edge of the boxes in relation to these imagined lines. You'll remember that 1 and 2-point perspective assume that the viewer is looking straight ahead, that the viewer's center line of vision is parallel to a flat ground plane. 3-point perspectives assumes we're tilting our head looking up or looking down. Like in this early Superman cover, here it's as if we're tilting our heads down, looking down from above. You'll find that 3-point's a staple of superhero comics. 3-point won't be totally foreign to you. In fact, you've already drawn an object in 3-point perspective, though I didn't describe it that way. It's the box we drew in the lecture on proportion. We were looking down to get a lot of complex angles. As with 2-point perspective, we have a right and left vanishing point to express width or depth, but we also have a third vanishing point expressing height. In this case, the box's vertical edges appear to angle down toward a common point way below. We only have time for a brief introduction to 3-point, but let's draw a block as if we're looking down. Start with the page in the landscape position. The first part of this will be just like drawing a block in 2-point perspective. We'll draw a horizon 1 inch from the top of the page. Then add vanishing points about 1/4 of an inch from the page's edges. We'll make a small mark 2.5 inches below the horizon, centered in the page. This will be the top front corner of the block. From this point, we'll draw a 2-inch vertical line straight down. This will represent the box's height. 1.5 inches on either side of this will draw a light vertical construction line. From the block's top front corner, we'll draw diagonals back toward both the right and left vanishing points, stopping at the vertical construction lines. Then erase your construction lines. From the line on the right, we'll draw a diagonal toward the left vanishing point, and from the left to the right vanishing point. Next, from the center bottom of the block, we'll draw lines back to the right and left vanishing points. Now we need our third point. We'll locate this vanishing point 1/4 of an inch from the bottom of the page and centered in its width. From each corner, we'll draw a diagonal down toward the third vanishing point, stopping where we intersect the lower diagonal. You're done. And if you rotate your page 180 degrees, you'll have an example of 3-point perspective, but this time looking up. You could take some time to play with this page, try blocks to the right and left, and of course you could turn them into buildings or other objects. You can, of course, create the sensation of looking up or down using 1 or 2-point perspective and place things above or below the horizon. And historically, that's what many artists have done. In fact, I don't know of any drawings by Leonardo, Raphael, Durer, Canaletto, Ingres, or Akins that use 3-point perspective. And there are some pretty dramatic uses of 1-point perspective to achieve this, like this 17th century ceiling fresco in Florence's Pitti Palace by Agostino Mitelli. You've now done 3 major perspective drawings: the quad, the gridded room, and your constructed room. After doing the first 2, you learned how to draw curvilinear forms and pattern in perspective. In this lecture, you added 2-point perspective and sloping planes. No reason not to work into all 3 drawings to apply your new knowledge. You should be a good bit of fun. This lecture concludes our investigation of line, and you've learned a tremendous amount about its complexities, but I'm sure you're anxious to learn about value and light and shade, and that's just where we're going to turn next.